In this video, we will look at problems involving several people working together to complete a project. For example, if Adam does a job in 4 hours, it would be a reasonable deduction that each hour he gets 1/4 of the job done. If Betty does the job in 12 hours, it would make sense that each hour she's getting 1/12 of the job done. Together, in each hour, we need to add these to find out how much work is done. Adam did 1/4 of it, Betty did 1/4 of, or 1/12 of it. And if we add those together, getting common denominators, we find out that 1/3 of the job is done each hour. This means, working together, doing 1/3 each hour, it would take 3 hours to get the entire job done. We use this idea to come up with our work equation. Our work equation will always be the reciprocal of the first person's time plus the reciprocal of the second person's time equals the reciprocal of the teamwork time. The key to setting this up is to always use reciprocals to get our per hour output. Let's take a look at some problems where we can use this work equation in order to solve. Here we have Catherine, who paints a house in 15 hours. We have Dan, who does it in 30 hours, and we want to know how long it will take the team to do the job. We can set this up as a rational equation using the reciprocal of Catherine, 1/15, plus the reciprocal of Dan, 1/30, will equal the reciprocal of the team, 1/x. This is a rational equation which we can solve by using the least common denominator. 15 and 30 will give us 30, and we also need a factor of x. So we'll multiply each term by 30x. As we do, we can reduce out 30/15 is 2. The 30's divide out, and the x's divide out. We end up with 2x times 1, or 2x, plus 1 times x, or x, equals 30. Combining like terms tells us that 3x equals 30. And if we divide both sides by 3, we can conclude that x, or the teamwork time, is going to be 10 hours working together. Let's take a look at another problem where we're given some information and have to deduce how long it will take the team, or the individuals, to get the job done. In this problem, we see that Evan can clean a room in 3 hours. His sister Faith helps, and as a team, it takes them 2 2/5 hours. We don't know how long it would take Faith alone. And also, we've got the problem that the teamwork time is a mixed number. So let's change this to an improper fraction, which would be 12/5, by multiplying 5 times 2 and adding the 2. And then we can set up our equation using the reciprocals. The reciprocals of the individual will equal the reciprocal of the team. So Evan's reciprocal, 1/3, plus Faith's reciprocal, 1/x, equals the team's reciprocal. The reciprocal of 12/5 is 5/12. Now we can solve by multiplying everything by the least common denominator, which will be 12x. Multiplying by 12x on each term, 12/3 reduces to 4. The x's divide out, and the 12's divide out, and we're left with 4x plus 12 equals 5x. We see we simply need to move the variables all to the same side by subtracting 4x, and we end up with 12 equals x. In other words, it will take Faith 12 hours working alone to get the job done. The teamwork equation of adding the reciprocals to equal the reciprocal of the team can help us identify how much time it will take each person, or the team, to get the job done.